Hello, dear listener, and welcome to this quiet space, as we drift together into the vast and wondrous cosmos, seeking moments of peace and profound understanding before sleep gently embraces us. Tonight, we'll embark on a journey not through the physical stars, but through the realm of human dreams and scientific ambition, to a place far, far away, shrouded in an ethereal, golden haze. Our destination is Titan, Saturn's largest moon, a place of extraordinary beauty and profound mystery, and we will softly explore the story of a mission, a concept, a whisper of what could have been, the Titan Mare Explorer, or Time. Imagine, if you will, the serene quiet of a star-filled night. Beyond our familiar Earth, beyond the fiery embrace of our Sun, lie worlds sculpted by forces we can only begin to comprehend. And among them, orbiting the ring jewel of our solar system, Saturn, is Titan. It is a moon unlike any other, holding secrets that tantalize our scientific minds and spark the deepest wells of our philosophical curiosity. For on Titan, under a thick, hazy atmosphere, there exist vast, tranquil seas and lakes, not of water, but of liquid hydrocarbons, methane and ethane. The very idea of a sea on another world, a liquid body reflecting an alien sky, is a concept that truly stretches the imagination. And it was this extraordinary vision that inspired the Titan Mare Explorer. Time was not merely a probe. It was a dream, a proposed design for a lander, a vessel of exploration designed to gently touch down upon one of these extraterrestrial seas. Think of it, a nautical exploration, the very first of its kind, on a world millions of miles from home. This alone speaks to the boundless spirit of human endeavor, our innate drive to venture forth, to understand, to touch the untouchable. This mission, conceived by Proxima Research and proposed to NASA in 2009, was envisioned as a relatively low-cost, yet incredibly ambitious, outer-planet endeavor. In the grand tapestry of space exploration, low cost often implies ingenious design and a focused scientific objective, a testament to what can be achieved with brilliant minds and a clear purpose. Time aimed to be a scout, a pioneer, daring to dip its instruments into the chilled, alien waters of Titan. Its primary goals were elegant in their simplicity, yet profound in their implications: to measure the organic constituents within Titan's seas, to analyze the very nature of these mysterious liquids, and perhaps most captivatingly, to observe its shoreline. Imagine, standing metaphorically at the edge of Ligeia Mare, looking out across a calm, dark expanse under an orange sky, witnessing the gentle lapping of methane waves against an alien shore. What stories would those shores tell? What geological forces shape them? What forms might chemistry take in such an environment? Time was part of NASA's Discovery program, a series of missions characterized by their focused scientific objectives and cost efficiency. It reached the finalist stage, a moment of hopeful anticipation for the scientific community, for those who dreamt of sailing on alien waters. 3 missions were chosen as finalists in May 2011, each receiving a generous $3 million to develop a detailed concept study. The other 2, InSight, which would later journey to Mars, and Comet Hopper, a mission designed to hop across a comet's surface, represented different facets of our desire to explore. Time stood unique among them, a maritime explorer, a quiet ship for an alien ocean. But alas, after a thorough review in mid-2012, NASA ultimately selected InSight for Mars. Despite further attempts in the U.S. Senate to secure special earmark funding in 2013, the Time mission, in its original form, did not come to fruition. Yet the dream, the vision, the scientific imperative, continued to ripple through the minds of researchers. Indeed, the very idea of exploring Titan's liquids persisted, with related concepts like a Titan submarine even being proposed, a testament to the enduring allure of this enigmatic moon. Let us now delve deeper into the wonders of Titan itself, the stage upon which this extraordinary mission was meant to unfold. The understanding of Titan has evolved over time, each new discovery peeling back another layer of its atmospheric veil. It wasn't until July 22, 2006, that the scientific community received confirmation of what had long been hypothesized: the presence of lakes and seas in Titan's northern hemisphere. This monumental discovery, made possible by observations from the Cassini spacecraft, transformed Titan from a mere scientific curiosity into a world of active, dynamic processes, a place where liquids flowed and pooled, a mirror image, in some profound sense, of our own Earth. And what liquids these are! We speak of methane and ethane, hydrocarbons that exist as gases here on Earth, but on Titan's frigid surface, under a pressure not dissimilar to Earth's sea level, they flow and gather as rivers and lakes. This realization opened a new chapter in planetary science, challenging our Earth-centric view of what constitutes a habitable, or interesting, world. Here, the very stuff of our natural gas, our fuels, exists in a state we recognize as liquid, forming a cycle analogous to Earth's hydrologic cycle. Imagine, if you will, the gentle falling of rain on Titan. But this is not water rain, it is methane rain, perhaps a soft drizzle, or perhaps a sudden downpour, transforming the landscape. The text tells us that while most of Titan experiences centuries without seeing any rain, precipitation is expected to be much more frequent at the poles, precisely where these vast seas are found. So, picture a northern winter, where the sky, a deep orange, weeps liquid methane onto the dark, still surface of Titan Mare. This precipitation feeds the rivers, carving channels into the icy terrain, and replenishes the lakes, maintaining their majestic presence. Clouds, too, form in this alien atmosphere, made of methane ice particles, drifting lazily across the sky, casting faint, shifting shadows on the surface below. The Time mission would have directly discerned this intricate methane cycle, helping us to understand its unique characteristics and, crucially, to draw parallels and identify differences with the familiar hydrologic cycle of Earth. What could we learn about planetary processes by comparing these two systems, one based on water, the other on methane? It's a profound question, hinting at universal laws of fluid dynamics and atmospheric circulation, yet played out with entirely different chemical players. Beyond the meteorological, Titan also hints at internal geological activity. Previous observations of southern polar storms and newer observations in the equatorial region provide evidence of active methane-generating processes. These could be cryovolcanic features, like volcanoes but erupting not molten rock, but perhaps a slushy mixture of water ice and ammonia, or even liquid hydrocarbons, from Titan's interior. This suggests that Titan is not a geologically dead world but possesses an internal engine, a source of heat that drives these processes, further contributing to the methane cycle and perhaps even shaping its unique surface features. It adds another layer of dynamic complexity to this already fascinating moon. Had Time been selected, it would have been led by Ellen Stofan, a distinguished member of the Cassini radar team and later NASA chief scientist. The Applied Physics Laboratory, APL, would have managed the mission, with Lockheed Martin constructing the capsule, and scientific instruments provided by APL, Goddard Space Flight Center, and Malin Space Science Systems. This collaborative effort speaks to the immense pool of talent and dedication required for such a sophisticated endeavor, a true symphony of human ingenuity. Let us now gently turn our thoughts to the specific journey Time would have undertaken. Its launch was envisioned with an Atlas V-411 rocket, a powerful workhorse of space travel, during 2016. After a 7-year simple interplanetary cruise, a long, quiet drift through the cosmic ocean, it would have arrived at Titan in 2023. Imagine that journey, 7 years, sailing silently through the void, bathed in the distant light of our sun, slowly but surely closing the vast distance to Saturn and its captivating moon. There would be no dramatic flyby science during this cruise, just the focused trajectory, the patient approach, the steady anticipation of its ultimate destination. The chosen target, a jewel within Titan's crown of seas, was Titan Mare. Picture this name, Titan Mare, whispered softly in the darkness. It is one of the largest lakes on Titan identified to date, stretching across a surface area of approximately 100,000 square kilometers, or about 39,000 square miles. To give you a sense of its scale, that's larger than Lake Superior, one of Earth's Great Lakes. A truly immense body of liquid, reflecting the strange light of Titan's sky. Its coordinates, 78 degrees north, 250 degrees west, place it firmly in the northern polar region, a realm of perpetual twilight during the northern winter, a time of profound darkness and quiet contemplation. The backup target, equally majestic and mysterious, was Titan Mare, another colossal sea awaiting exploration. Upon arrival, Time would have performed some crucial science measurements during its entry through Titan's thick atmosphere and its subsequent descent. But the true heart of the mission, the data transmissions that would captivate scientists and inspire dreamers, would only begin after splashdown. Imagine the moment, a gentle descent, perhaps a soft hiss as it breaks the surface, then the quiet bobbing on a hydrocarbon sea, millions of miles from the nearest human. And then, the instruments would awaken, beginning their silent work. The science objectives were meticulously crafted, designed to unveil the deepest secrets of this alien ocean. Let us ponder each one, and what it truly signifies. Firstly, to determine the chemistry of a Titan sea. This is fundamental. What are the precise organic constituents flowing within Titan Mare? What intricate chemical reactions might be taking place in such an environment? The instruments designed for this task, a mass spectrometer, MS, and a comprehensive meteorology and physical properties package, MP3, would have been our sensory organs in this alien world. The mass spectrometer would meticulously analyze the composition of the liquids, identifying the different hydrocarbon molecules present, perhaps revealing complex organic compounds that could be precursors to life, or entirely new forms of chemistry we have yet to imagine. This objective delves into the very essence of what makes Titan seas unique, and what potential they hold for understanding the origins of life, not just on Earth, but anywhere in the cosmos. It asks, what is this liquid made of? And what does its composition tell us about the history and future of this enigmatic world? Secondly, to determine the depth of a Titan sea. This might seem straightforward, but its implications are vast. The MP3 package, equipped with a sonar, would emit acoustic waves, listening for their echoes from the seabed. Knowing the depth of Titan Mare would allow us to calculate its volume, to understand the topography of its basin, and to infer the geological processes that shaped it. Is it a deep, ancient basin, or a shallower, more dynamic body? Does its depth vary significantly, suggesting underwater features, hills, or valleys? The sound of sonar pinging into liquid methane, echoing through the depths of an alien sea, imagine that lonely, searching sound in the profound silence of space. Thirdly, to constrain marine processes on Titan. This objective aims to understand the dynamic interactions within the sea itself, and with its surroundings. The MP3 and descent ensue. Phase cameras would have been our eyes and ears. Are there currents, waves, or tides? How does the liquid interact with the shoreline? Do erosion and deposition occur, shaping beaches and deltas? What forms do these processes take in a world of methane? Imagine the cameras capturing the gentle lapping of waves against a dark, rocky shore, or perhaps the formation of unique ice features as methane freezes and thaws. This objective helps us understand the behavior of this alien ocean, how it breathes and moves. Fourthly, to determine how the local meteorology over the sea varies on diurnal timescales. Diurnal timescales refers to changes occurring over a Titan day, which is equivalent to about 16 Earth days. This objective, primarily using the MP3 and cameras, would measure wind speed and direction, methane humidity, pressure, and temperature above the waterline. How do these atmospheric conditions change as Titan slowly rotates, presenting different faces to the dim sunlight? Do winds whip up across the surface, creating visible ripples or whitecaps? Does the methane humidity rise and fall, foreshadowing precipitation? Understanding these daily cycles is crucial for grasping the dynamic interplay between the sea and the atmosphere above it, how they influence each other in a continuous, gentle dance. And finally, to characterize the atmosphere above the sea. Building upon the previous objective, this involves a broader understanding of the gaseous envelope and the immediate vicinity of the sea. Again, the MP3 and cameras would be key. How does the atmosphere directly above the sea differ from the atmosphere further inland? Does the presence of a vast liquid body influence local cloud formation, or create unique microclimates? This objective connects the fluid surface to the vast, hazy atmosphere, giving us a more complete picture of Titan as an integrated system, a living, breathing world. The visual component of time was particularly exciting. Malin Space Science Systems, renowned for building and operating camera systems for spacecraft, had an early development contract to conduct preliminary design studies. There would have been 2 cameras, one to capture stunning images during the descent to the surface of Titan Mare, allowing us to witness the approach to this alien ocean in real time. Imagine the gradual resolution of the surface, the faint shimmer of the liquid, the hazy horizon. And the other camera would have taken pictures after landing, offering us the opportunity to see the serene expanse of the sea, the alien shoreline, and the strange, beautiful sky of Titan from a truly unique perspective. These images, more than anything, would have brought Titan to life for all of us, transforming abstract data into tangible wonder. The Meteorology and Physical Properties Package, MP3, a marvel of engineering, would have been built by the Applied Physics Laboratory, APL. This comprehensive instrument package was designed to measure not only the atmospheric conditions above the liquid, wind speed and direction, methane humidity, pressure, and temperature, but also crucial properties below the surface. Imagine these sensors, gently submerged in the cool methane, measuring turbidity, the cloudiness or clarity of the liquid, sea temperature, the speed of sound within this alien fluid, and its dielectric properties, how it responds to an electric field. These measurements would be our ultimate window into the physical nature of a Titanian sea, revealing its true character, its hidden depths, and its subtle movements. The sonar, an integral part of the MP3, would probe the very bottom, mapping the unknown topography of the seabed. Acoustic propagation simulations were performed, and sonar transducers were even tested in liquid, demonstrating the feasibility of this extraordinary endeavor. The thought of time, gently bobbing on Titan Mare, taking these silent, profound measurements, sends a ripple of serene contemplation through the mind. It speaks to our deepest longings for discovery, for understanding the grand tapestry of the universe. What if it had flown? What astonishing secrets would it have unveiled? What philosophical insights would it have granted us about the diversity of worlds, the potential for different kinds of chemistry, and perhaps, different pathways to life? Even though time itself was not selected, its spirit, its ambition, continues to resonate. The Solar System Decadal Survey, a guiding document for planetary science, recognized the importance of missions to land in Titan's lakes or seas. And the flagship Titan Saturn system mission, a much larger proposal, included a short-lived, battery-powered lake lander, a small echo of time's grand vision. This consistent interest underscores the profound scientific value of exploring Titan's liquid landscapes. Opportunities for such missions are fleeting, transient moments dictated by celestial mechanics. The text reminds us that the next launch opportunity was in 2023 to 2024, representing the last chance in this generation for certain planetary alignments. These cosmic windows of opportunity are precious, demanding foresight and decisiveness, and reminding us of the immense effort required to bridge the vast distances of space. As we gently bring our thoughts back from this imagined voyage, let us reflect on what the story of time, the Titan Mare Explorer, truly tells us. It is a narrative of human curiosity, of daring to dream beyond the familiar, of pushing the boundaries of what is possible. It is a story of meticulous scientific design, of brilliant minds working in concert to create a vessel capable of exploring an alien ocean. And it is a story that, even in its unfulfilled potential, inspires us to look up, to wonder, and to continue to seek knowledge beyond our earthly home. As you prepare to drift into sleep, let the image of Ligeia Mare, a vast, calm sea of liquid methane under a hazy, orange sky, gently settle in your mind. Imagine the time lander, a silent observer, floating on its surface, its instruments listening to the murmurs of an alien world. Feel the profound peace that comes from contemplating such immense distances, such alien beauty, such boundless mystery. The universe is a place of endless wonders, and our journey to understand it is a testament to the quiet power of the human spirit. Rest now, dear listener. Let your thoughts wander to the distant shores of Titan, to the gentle lapping of its methane waves, and find solace in the knowledge that even in our sleep, the universe continues its silent, majestic dance. May your dreams be as vast and peaceful as the seas of Titan. Good night.